types of cutting tool materials, this particular cutting tool material can be operated under high speed condition. That's why it is called as high speed steel. Okay. What I want to tell is the first cutting tool materials, plain carbon tool steel and alloy tool steel. Okay, these two tool materials can be operated at very slow speeds compared to the cutting speed. This high speed steel, okay, when they kept on developing the cutting tool material, okay, they felt that high speed steel can be operated under high cutting speeds compared to the previous two cutting tool materials, that is plain carbon steel and alloy steel, okay, alloy tool steel. So that's why it is named as high speed steel. But there is a limitation for this also. It has a maximum temperature range of something around 500 or 600. Okay, beyond that we cannot use this as a cutting tool material. It will lose its property. Okay, it is maximum is 600. Why I am telling 500 or 600? The properties and the highest possible cutting temperature also varies according to the type of alloying elements which are present in this cutting tool material. Okay, when we increase the content of tungsten, okay, it can even withstand higher temperature. But when we reduce the percentage composition of tungsten, okay, it cannot withstand even up to 600 degrees centigrade. Normally, this high-speed steel tool steel will have this tungsten, molybdenum, chromium, vanadium, cobalt. So these are all some of the materials which are normally present in such type of tools. Okay, tungsten is W, molybdenum is MO, chromium Cr, vanadium V, and cobalt CO. Okay, all these items or all these materials are added in proper percentage so that we could able to produce this particular tool steel. Okay, just a minute. And this is also quenched in oil, air, or salt solution. Okay, it may be the property of this material may be changed either by dipping, okay, the hot high speed steel in such material like oil, air, or salt. And the next one is they are capable of retrieving high hardness up to 600 degrees centigrade, as I have mentioned. Okay, because of it can be operated much higher speed compared to the other tool steel. Already I have explained. The two basic types of high speed steels are tungsten type, which is called as T series. Another one is molybdenum type, that is M series. Okay, so when molybdenum is included, it will be called as M series, and tungsten is there at higher proportion. Automatically, the name is given as T series. Okay, M series is cheaper than molybdenum material is cheaper than tungsten. That's why M type or M series is comparatively cheaper than T series. And that in this particular T series, the popular type of high speed steel, which are normally used even in our lab, is 1841 high speed steel. Normally, this question would be asked even in your interviews or in competitive examination. What is 1841 high speed steel? Okay, a type of high speed steel is called as 1841 high speed steel. So the 18 means it contains 18 percentage of tungsten, 4 percentage of chromium, and 1 percentage of vanadium. But there are other elements may be added to increase the hot hardness. But these three materials will have the proportion or composition or percentage composition 1841. 18% tungsten, 4% chromium, and 1% vanadium. Okay, the carbon content is maximum up to 0.75 percentage. Okay, there are different grades, T grades and M grades. The commonly used M grades are M1, M2, M7, M10, T1, T2, M2. Okay, these are all some of the grades which are available under M grade as well as T grade or T series. Then high speed steel with cobalt. Okay, sometimes as I have mentioned, cobalt also will be added to increase the hot hardness. Okay, there is a grade T6 grade. The T6 grade is called as super high speed steel. Okay, which grade of HSS is called as super high speed steel? Okay, you must know the answer. It is T6 grade. So T6 will have a particular combination of alloying elements. Okay, the percentage composition will vary, but that is not given here. Okay, they are less tough than other types. Okay, so it must be supported by rigid machine tools. Okay, but it is most expensive. That means hardness. It can withstand very high temperature as well as the hardness of this material is very high. So we can use it even at high temperature, but the problem is the toughness is low. Okay, whenever we increase hardness, automatically toughness will keep on reducing. So this particular grade T6 or super high speed steel has got very high hardness but less toughness compared to the other grades of steel. Okay, high speed steel with high percentage of vanadium. Okay, the vanadium is added mainly to increase the hot hardness or red hardness and wear resistance. So according to our requirement, we can prefer a particular type of high speed steel. Okay, whether it may be T6 grade or vanadium, that is maximum amount of vanadium. Okay, so that we can achieve the required property. Normally, this high speed steel is produced by powder metallurgy. Already we have studied what is powder metallurgy. Okay, making components by mixing the required powders, metal powders, and compacting that, followed by sintering operation. Okay, sintering is nothing but heat treatment. Then we have to do some fine finishing operation. Okay, so that we can use it as a cutting tool material. So it has got higher wear resistance, greater toughness, but don't feel that this is having highest possible wear resistance. Not like that. Compared to the previous cutting tool materials, this particular material has got a higher amount of wear resistance and higher amount of toughness, okay, and impact strength, better hard workability, machinability, grindability, and material removal rate. Okay, so that is given. The next cutting tool material is non-ferrous cast alloy, okay, which is called as stellite. Okay, stellite contains cobalt, chromium, tungsten, and carbon. Okay, so why it is called stellite? It is a non-ferrous cast alloy. That means there is no iron content or ferrous content in this particular cutting tool material. Normally, all the cutting tool materials will have at least a small percentage of ferrous, but this doesn't have any ferrous content. That's why it is non-ferrous cast alloy. 1% carbon may be added, but cobalt, chromium percentage are varying. Okay, 3% carbon content may be having higher resistance to wear. Okay, and these have intermediate properties between high-speed steel and cemented carbide. Cemented carbide tool steel we are going to study. Cemented carbides are also made through this powder metallurgy technique. We are mixing carbon powders, iron powders, titanium powder, then tungsten powder, tantalum powder. So according to our requirement, we will be mixing the concerned powders in proper proportion so that we can able to generate that particular cutting tool material. The next one is, yeah, as I have mentioned, it is a sintered carbide or cemented carbide. Both are same. Don't think that sintered carbide is different from cemented carbide compared to the other materials like alloy steel or high speed steel. This has got a higher value of hot hardness or red hardness. It can withstand a temperature up to 1000 degrees centigrade. If you take the high speed steel, the maximum temperature or cutting temperature up to which it can work well is 600. But if you take alloy steel, the maximum temperature or cutting temperature is limited to 300. But for the plain carbon steel, it may come up to 100 or 200 degrees centigrade. Okay. So compared to the previous version, this has got a higher value of hot hardness that may go up to 1000 degrees centigrade. But we have other materials which can even withstand higher temperature. Okay. There are three general groups. Okay. So one with straight tungsten carbide. Okay. That is tungsten carbide with cobalt as binding material. Okay. So we'll be adding tungsten powder with carbide powder. In this, the cobalt is added as a binding material. Okay. So cobalt will have the binding property. So in carbide tools, normally we are using this cobalt as the binding material. Okay. Then tungsten carbide with cobalt as binding again, but it will have other elements like titanium, tantalum, nobelium, okay, along with tungsten carbide. So these are all the materials which are added so that it will have some improved properties. Then titanium carbide with nickel or molybdenum as binding material. Okay, we can also have nickel or molybdenum as binding material, but most commonly used binding material is cobalt. Okay, so the next one is ceramics. Okay, the word ceramics is nothing but aluminum oxide, that is Al2O3. Al2O3 or aluminum oxide or ceramics or ceramic oxide is used as a cutting temperature, okay, which can withstand even above 1000 degrees centigrade, as this material is sintered at 2200 degrees centigrade. So the hot hardness or the resistance offered to heat or at cutting temperature is much higher compared to the previous materials. Okay, it has got high hot hardness and higher comparative compressive strength, but the limitation or the drawback is it is highly brittle in nature. See here, the highest possible working temperature is 1200 degrees centigrade. So the cutting speed may be 40 times higher than the high speed steel. See, we have been thinking that high speed steel is the speed steel which can be operated at very high cutting speed. Not like that, but aluminum oxide or ceramic can be operated even 40 times higher than the cutting speed or normal cutting speed of high speed steel material. Okay, they are used for single point cutting tools. Okay, for cast iron or plastic. Okay, example for single point cutting tools are shaping tool, slotting tool, okay, then lathe tool, thread cutting tool. All these cutting tools are example for single point cutting tool. No coolant is needed when we go for this. So in dry machining or dry cutting operation, we are preferring this aluminum oxide or ceramic as the cutting tool material. But the another limitation is it is costly when compared to cemented carbide, high speed steel or alloy steel. Okay, so whenever we prefer high quality uh, cutting tools which can withstand very high temperature, okay, normally it will be costing more. The next one is CERMET. CERMET is ceramic plus metal. CER, the first three letters stands for ceramic. The next three letters, it is metal. Okay, that's why it is called as CERMET, ceramic and metal. So these two are mixed together, or the combination of ceramic and this one. Ceramic material is aluminum oxide, okay, Al2O3, a commonly used ceramic material. But there are other ceramic materials are also available. Okay, in our cutting tool material, the commonly used ceramic material is Al2O3 or aluminum oxide. So it will have the properties both ceramic as well as metal. Okay, another important purpose of adding ceramic. Okay, we are all using ceramic tile in our home. Okay, we are using lot of ceramic tiles. The reason is it has got high wear resistance and hardness. Okay, if you use ordinary tiles, okay, instead of ceramic tile, you can immediately within 1 month or within 1 year, you will notice the scratches on the surface of the tiles. But when we go for the ceramic as the material, it has got high hardness and abrasion resistance. Okay, it can withstand this ceramic material when it is cut into pieces. The edges are very sharp. Okay, it will act like a knife. Okay, so when we handle such ceramic tiles, especially the broken ceramic tiles, we have to handle it with care. It has got a high hardness and it will, the edges of the ceramic tiles, if it is not chamfered or if it is not mm, polished, okay, so the edges will be very sharp compared to the normal knives. Okay, the next one is the metallic elements used are nickel, molybdenum, and cobalt. So these three materials are commonly used, but the ceramic material, it may be aluminum oxide or even boride. Okay, boride material is also used as the ceramic material. Okay, so the ceramics usually having, okay, depending on the physical structure, okay, the material can be used as metal matrix composites. Okay, the cermet is example for metal matrix composites. So metal matrix composite, very good example is aluminum matrix composite or magnesium matrix composite. Okay, the more amount of aluminum which will be mixed with ceramic powders. Okay, it may be aluminum oxide, silicon carbide, okay, titanium oxide or titanium carbide. Okay, such ceramic materials would be added with aluminum to form the aluminum matrix composites. Okay, same way here also we are mixing both metal as well as the ceramic in the form of the composite material. The next one is diamond. Okay, diamond material is the hardest available material. We all know that the cutting speed at which we can do the machining may be 50 times higher than high speed steel. Okay, so it can withstand very high temperature so that we can able to operate the machine tool 50 times higher speeds than the speed which we can achieve through high speed steel cutting tool material. It can resist temperature up to 1250 degrees centigrade. So the hot hardness is higher when compared to even ceramic material. Okay, it, the problem is the limitation we want to tell about this particular material is it's very costly. Okay, so it's one of the costliest material in the world. And another one is it is highly brittle. Okay, so it is having very poor brittle resistance. Okay, so what we have to do is we have to fix this diamond as the cutting tool material in machine tools which are free from vibration or chatter. Okay, if the machine tool is highly sophisticated and very good vibration damping facility is available, means we can try this particular material as the cutting tool